Hey everyone, welcome back. Today we are diving into a crucial aspect of data analysis in Python, handling dates using pandas. Whether you are working with time series data or need to manipulate dates for various analysis, pandas is an essential tool. In this session, we will explore some of the most useful date functions and see how they work in action. So let's get started. I have imported the necessary libraries, pandas and numpy for our task. And now let's create a data frame with some data for demonstration purpose. Data equal to date. Let me create a list 2024-01-01, 2024-02-15, 2024-03-10, 2024-04-25, and let me add some sales values 100, 200, 300 and 400. Let us create a data frame df pd.DataFrame and let us pass this data print df. You can see we have successfully created a data frame with one of them is a date column and the other one is value column. Let's use df.info method, and you can see here date column is an object data type, whereas value is an integer data type. Here we have set up a data frame with date column containing date string. Now, if we want to manipulate dates in pandas, we have to convert the string date type into date time data type in pandas. Let's see how we can do that. Df column name date. We are going to call pd.to_date time df date. Let me write here convert string dates to date data type in pandas. So to_date time is the function through which you can convert a string date type into date time data type in pandas. Let's run the code. Now let's use the info method and see that. And you can see here date field has been converted successfully from string data type to date time data type. You do not see any difference because the format is correct here. But at the back end, you need date time data type in pandas to manipulate the date time fields. So by using the to_date time function, we convert these strings into datetime objects. Now that our dates are in datetime format, let's explore some useful functions and operation. First, we will extract various components of the date such as year, month and day using the .dt accessor. We can easily retrieve these components from the date field. Let's see how we can do that. We have a data frame df. We will create a new column called equal to df date. Now we will call our dt accessor and year. Let me copy this. I will create another column called month, and here I'll change year to month, and df day equal to df date dot dt accessor and day. Let's run the code. Let's print the output df, and you can see here we have successfully retrieved year, month and day from a date field from the df data frame. By extracting these components, we can gain valuable insight for a time-based analysis. Next, let's calculate the difference between the dates. We will calculate the number of days between each date and the first date in our data frame df. what we are going to do here, we are going to create a new variable called first date equal to df date dot min. This will compute the first date in a data frame. Print first date, and you can see here we have successfully retrieved the first date from a data frame df. Now we are going to create a new column in a df data frame, days underscore since underscore start equal to df date minus first date. Let's run the code. Print df. You can see here we have successfully retrieved number of days from the start: 0 days, 45 days, 69 days and 115 days. But you see here there is one small problem. We are getting days in the end in our days underscore since underscore start column. How we can get rid of? Let's put up the braces, then dot dt dot days. Let's run the code. Now let's print the output, and you can see here we have got rid of days from the end in our column days underscore since underscore start. Here we subtract the minimum date from each date to get the number of days that have passed. This operation is vectorized, making it both efficient and straightforward. Another handy function in Pandas is date underscore range function, which allows us to generate a sequence of dates. Let's create a date range for January 2024. Let me create a new series called date underscore range, pd dot date underscore range. Now let me pass the parameters start 20240101 and equal to 20240131, and frequency is going to daily because we want to have a daily data for January 2024. Let's run the code. Let me show you the output. Date underscore range, and you can see here we have successfully created January 2024 date range. It's with a daily frequency here, but you can adjust the frequency parameter, this particular parameter, frequency parameter, to generate different intervals such as monthly or hourly. Let's say if I change it to 1231 and if I change it to M, and you can see here we have generated a monthly date range for us by just changing the parameter, and you have to make the tweaks at the start and the end fields also. And that is how you can use date range function to generate the sequence of dates in Pandas. Whenever you are dealing with date time field in any data set, one of the most common tasks is to convert the daily date field to a monthly period field. Let's do an example and see how we can do it in Pandas. df underscore sales equal to pd dot data frame. Let me create a date field here. Date pd dot date underscore range function. Start equal to 2024-01-01. Periods equal to 100. So we are going to have 100 days. Frequency is going to be daily. Now let's add some sales. Let me put up range 1 to 100. Oh, I forgot to put up a dictionary. Sorry. Let me show you how our data looks like. Print df underscore sales dot head. And you can see here we have a daily date field and there are some arbitrary sales numbers are here. And we have to convert this daily date field into a monthly field. Let's see how we can do it. df underscore sales monthly underscore period df underscore sales date dot dt to underscore period, and you have to pass here m. So this particular function to_period is going to help us to convert a daily date field into a monthly period field. Let's see how does our data looks like. Let me print the output df_sales dot head, and you can see here we have successfully created a monthly period field 22401 from the daily date field. Let me show you. Let's use the tail method to see the last 5 records. And you can see here we have successfully extracted the month and year information from this date field. Now there is one trick. If you want to convert this monthly period thing into a monthly date field, how you can do it? It is very simple. dt.to_time. Now let's run the code. And this is how, using to_period function, we convert daily dates into the period index with the monthly frequency. Finally, let's discuss handling time zones. Suppose our dates are in UTC and we want to convert them to a different time zone. Let's see how we can do it. df_sales date df_sales then to_localize. First convert it into UTC time zone. TZ. Now let's see. Our date field has changed a little bit because it has been converted into the UTC time zone. Now let's say if we want to convert into New York EST time zone, how we can do it? df_sales ny date df_sales .dt.tz _convert, and then there are hundreds of time zones are available in tz_convert, and we are going to use America/new_york. You can refer to Pandas documentation. You will get all the information there. And you can see here we have successfully converted the date from a UTC time zone to a New York time zone, which is EST. So here, by using tz_localize sets the time zone to UTC, and tz_convert changes it to EST time zone for New York. This is especially useful for working with the global data across different time zones. And that's a wrap on handling dates with Pandas. We have covered converting data strings, extracting components, calculating differences, generating date range, and managing time zones. Pandas offer a robust set of tools for date manipulation, essentially for any time series analysis or date-based computation. If you have any questions or topic you would like us to explore, please leave a comment below. Thanks for watching, and I'll see you in the next video.